Hi everyone and welcome to the Age. We are under trigonometry and we are busy with general solutions, meaning that we are solving for angles of these trig ratios. In this case, we have to solve for y. And we know that with general solutions, you only want to get to a point where you have a single trig ratio on the left hand side or the right hand side, and then on the other side you have a number, right? So that you can be able to solve for an angle. You don't want a situation where you have two trig ratios, like in this case. We have both cos and sine. But when we look at cos and sine, we can see that sine is a double angle because it's sine 2y, whereas cos is just a single angle, so there's not much that we can do there. So let us focus on the sine 2y since it's a double angle. We know that we can change it. We have our double angle formulas. But we know that with sine 2 angle, we only have one form. So we can go ahead and change this into this form. So we're going to get cos y is equal to 2 sine y cos y, right? Great. Now, over here, it's going to be tempting to say, oh, okay, there is cos y on both, so we can, on both sides, so we can just cancel like this, right? That is incorrect. When we are dealing with general solutions, when we are dealing with solving angles, you do not want to cancel the trig ratios, because now you're going to be losing certain information when you cancel out trig ratios. And now I know it's frustrating. It's like, okay, what do we do? Because technically, mathematically, it's correct to cancel something when they are the same on both sides, right? Yes, but look at this. When we transpose this 2 sine y cos y to the other side, it's going to be cos y minus 2 sine y cos y is equal to 0. And then we can see that in both terms, cos y is a common factor, so we can factor out cos y 1 minus 2 sine y, right, is equal to 0. So had we canceled the cos y over here, we were only gonna be left with this bracket over here without the cos y. We're only gonna be left with 1 minus 2 sine y. Obviously, if you're gonna take it to the other side, it was gonna be 1 is equal to 2 sine y. We were not gonna be able to work with cos y anymore. That's a problem because, like I said, we are losing certain information, so we are not going to get to our full solution. When we're dealing with general solution, we want to get to full solutions, and so we must make sure that we don't develop a habit of canceling out trig ratios. If it was just numbers, like for example, if there was a 2 here, then yes, you were gonna be able to cancel out these 2's. But that's only with numbers. With trig ratios, you do not cancel. You try to find a way to manipulate the equation without canceling, right? Cool. Now that we have established that, yeah, I did say the main point of general solution is we want a single trig ratio, but we still have cos and sine. So what then? But as you can see here, it's two brackets. They are equal to 0. We know that if brackets, no matter how many brackets are multiplying to each other and they are equal to 0, you can equate each bracket to 0. So yeah, we're going to say cos y is equal to 0, or 1 minus 2 sine y is equal to 0. So in both equations, now you're only dealing with single trig ratios. On this first equation, you're only dealing with cos. On the second equation, you're dealing with only sine. So yes, the statement holds true in that when you want to find the general solution, you only want to work with a single trig ratio. Yeah, we just had to understand that we are not supposed to cancel a trig ratio when they are the same on both the left hand side and the right hand side. So let's find another way. And here we found another way to separate it in such a way that it's going to be two equations, where on each equation it's a single trig ratio, right? So yes, you always want to look out for these type of tricks. So working with the first one, cos y is equal to 0. Let's find the general solution. We know that for a reference angle, shift cos the number on the right, which is 0 in this case. So ref angle, yeah, is going to be 90 degrees. And we know that with a cos diagram, cos, which quadrant is cos going to be 0, or rather positive. I don't know, 0 can either be positive or negative. So in this case, it looks like we cannot work with that in such a way that now it's a 0. So we cannot determine, is it gonna be on the CAST quadrant or what, because it's 0. So we don't know if it's positive or negative. 0 can either be positive or negative. So in this situation, what I like to do is, how I like to look at it is by a graph. We know that a cos graph looks like this. Yeah, it's 0 at 0 degrees. Or actually, wait, no. Yeah, it's 0 degrees. And we know that the amplitude for cos is 1. Yeah, it's 0 degrees, 180 degrees. No, not 180 degrees. 0, 90, 180, 270, and 360. So yeah, it's going to be 0, 90 degrees. Yeah, it's 180 degrees at -1. Yeah, it's 270 degrees. And yeah, it's going to be 360 degrees at 1 again. Please don't mind my ugly drawing. Hopefully you can see what I'm trying to imply here. So yes, in as much, yes, we did get the reference angle, and we know that at 90 the graph is 0, right? The amplitude is 0. So yes, it is indeed correct. So we can say y is equal to 90 degrees. And now we have to see, okay, how many degrees will we have to add to get to another 0? So we know that, yeah, it's at 90 it's 0. Yeah, it's going to be 0 again at 270 degrees. So what is the difference there? Just say 270 minus 90 is equal to 180 degrees, right? So we would want to, in order to get 0, we would have to add an extra 180 degrees again, right? Our reference angle is at 90. We start at 90, and then we want to keep on adding 180 degrees. I know all this time we've been saying 360 degrees, but in the case where cos is equal to 0, you have to look at it different. You have to look at it graphically like I did here. I think that is the best way to look at it and to understand what is going on. So yeah, at 90 degrees, the graph is 0. At 270 degrees, the graph will be 0. And if you keep on drawing again, you will see that, like, yeah, the difference between 270 and 90 is 180. The same way the difference is going to be with the other angles, it's going to be 180. So it's going to repeat itself like that again. And yes, that is the general solution for the first one. For the second one, for sine 2y, it's going to be, okay, if I completely simplify it, it's just going to be a half. And we know that the reference angle is going to be 30 degrees. Let me just confirm. Yes, it's 30 degrees. And so our solution is going to be 30 degrees plus k dot 36. Oh yeah, I forgot to say k is elementary to z. Never forget that. And then our second solution is, we know that at the cos diagram, sine is positive at the all quadrant and the sine quadrant, and the sine quadrant is 180 minus reference angle. So 180 degrees minus 30 degrees plus k dot 360 degrees, y is equal to 150 degrees plus k dot 360 degrees. So that's your two solutions for equation 2 and equation 1. It's this solution. So yeah, at equation 1, be careful. If there is a situation even when sine y is equal to 0, where you will have to draw a graph like I did here. So this graph is for cos, right? For cos y. So if you're going to get like I said, a trig ratio equaling to 0, Just go ahead and draw the graph. Make it much easier. Don't do the cost. Do the cost when it's anything but zero. But if it's zero, I would say use the graph method to determine your general solution, like we did, yeah. And I hope that made sense. I know it can be quite tricky, but if you're still confused, if you still have more questions, leave your questions in the comment section. And if you found value in this video, please hit the like and subscribe for more content like this. Thank you very much, everybody. Have a good day.